Hi, I'm Kelly, and this is Sam, and we're going to be explaining how to find the pH at the equivalence point of a titration problem. So here we have the question, what is the pH at the equivalence point for the titration of 500 milliliters of 0.042 molar propanoic acid with a 0.2 molar sodium hydroxide solution? So we're going to be doing stoich, then a Rice chart, and then finally a K expression to find the pH. So first we're going to find the moles of the acid. And to do that, you use molarity equals moles divided by volume, and we're given the molarity and also the volume. So you multiply the molarity times the volume in liters to get the moles of the acid. And we want to convert this to find the volume of the base that it takes to neutralize the acid. So here in the stoich problem, we have the moles of the acid, and then we have the 1-to-1 mole ratio that you get from the equation. We have 1 mole of base and 1 mole of acid. And then here, to get the moles of the base, we use the molarity in the problem again, and multiply, and the molarity is moles divided by volume. So it's 0.2 moles per 1 liter, which is also 1,000 milliliters. So you get 105 milliliters. And we use this to find the total volume, which is the 500 milliliters in the problem, plus the 105 milliliters to get a total volume of 605 milliliters. So now we can move on to our Rice chart. And here we start with the salt because at the equivalence point we have initially just salt. So we need molarities in Rice chart. So we divide the volume of acid that we have that we need to neutralize divided by the total volume. And we get a molarity of 0.03471 molarity. And then we have 0 of the base and acid. And then since they all have a coefficient of 1, you subtract x on the left side and add x to each on the right side. And then we have 0.03471 minus x, and then concentrations of x on the right side.
And we are going to use these values to plug into a K expression, which we did on the back of the board. So remember, on a K expression, you do the products on the top and the reactants on the bottom, and you do not include liquids. So first we need to figure out if we're going to use Ka or Kb. We're given Ka, but since our salt is on the left, we're going to use, we need to find a Kb value. So we're going to use Kw, which is 1 times 10 to the negative 14, and Kw equals Ka times Kb. So we're going to plug it in. So 1 times 10 to the negative 14 equals our Ka value, 1.3 times 10 to the negative 5 times Kb. So you're just going to divide the 1 times 10 to the negative 14 by the 1.3 times 10 to the negative 5 to get our Kb, which is 7.69 times 10 to the negative 10. And now we're going to use that to plug into our K value for our K expression and to solve for x. So here you see our K expression written out with numbers. So here's our Kb value that we just found. Here's our 2 x's that we found with our Rice chart that plug in for our products. And then here is the concentration for the reactants in our Rice chart. So we're going to ignore this x because initially if the x is small, when we figure out what x is, we can continue with our math, and if we have time, you can go back to make sure that it's less than 5% of the initial concentration. So we're going to continue by ignoring the x and multiplying our Kb value, 7.69 times 10 to the negative 10, times 0.0347, which is going to give us 2.67 times 10 to the negative 3, which equals x times x, which is x squared.
10 to the negative 11.
Oh, did I say 3?
Yes.
Excuse me. I don't know where that came from. And so then our x value equals, because we're going to square root this, 5.17 times 10 to the negative 6. And since this is the x value for OH, we're going to take the negative log of that to find POH. So you're going to plug that into your calculator, negative log of 5.17 times 10 to the negative 6, and that gives you a POH of 5.29. To get pH, you're going to do 14 minus that, and you get 8.71, which is your final pH.